Great. Good morning, everybody. Welcome to Unlock the Power of Open Source Database in Azure. My name is Dingding Lu, and I will be co-presenting this session with my co-worker, Aditi, AVIJIT, and our customer, 𝗦𝗲𝗀𝗶cie, he's from Quadrant. Before we get started, I just want to do a quick survey of raised hands. Please raise hands if you use Postgres. Great. MySQL? All right, Cosmos DB? Great, great. It's good to see some of you at least have some experience with one of the databases. All right, let's get started. So today, first, I will talk about the commitment that Microsoft made to the open source database. Then I will outline the contributions we made to the PostgreSQL community. And then Aditi will talk about the new capabilities with Azure Database for MySQL, and AVIJIT will provide the new update for Cosmos DB for MongoDB. All right, so as our CEO Satya once pointed out that we must learn to build the idea of others and to work together to make our dreams believable and achievable. Over the years, Microsoft has launched numerous open source projects and made huge contributions to the community. Here are some examples of those projects. I want to point out the first thing, Microsoft is the top one cloud vendor committer to Postgres, more than any of our competitors. Besides contributing to Postgres community, we also open source Microsoft's own products, such as Visual Studio Core and Azure Data Studio. Our today's topic will focus at the three open source databases, Postgres, MySQL, Cosmos DB for MongoDB, and how Microsoft makes those databases enterprise ready by ensuring it has enterprise-grade security, it is highly available and scalable to support our customer workloads. It is cost-effective and fully managed by Microsoft to be always up to the date with the latest major release. More importantly, those open source databases are ready for our customers to build cloud-native AI applications and leverage the full AI capabilities that Microsoft can provide. Our customer definitely recognize the value of enterprise-ready open source databases. We keep expanding our customer base for all those three databases. Here is just a list of some representative customers of MySQL, Postgres, and Cosmos DB. Now let's talk about Azure Database for PostgreSQL. Azure Database for Postgres is a fast-growing product that benefits from the collaboration between Microsoft and the Postgres core development community. At the same time, our team at Microsoft keep contributing back to the Postgres ecosystem. We also ensure our Postgres products are AI ready for mission-critical enterprise applications. If you are not very familiar with Postgres, it is the most popular database for professional developers in 2024 and in previous years. At Microsoft, we have 7 Postgres committers out of total 30 worldwide. We keep investing heavily in the core Postgres development community. We have a fleet of workstreams that continues to enhance our existing managed database services, such as Flexible Server and Cosmos DB for Postgres, as well as new products such as Elastic Cluster that is in preview today to support distributed and elastic query workloads. In the latest Postgres 17 release, Microsoft authored or co-authored 412 Postgres commits to enhance the Postgres core capabilities. Let's take a look at several of those new capabilities. Supporting streaming I/O is a significant step towards getting async I/O and direct I/O into Postgres. It improves the performance and efficiency of streaming reads. For example, it speeds up sequential scan by reading multiple buffers in a single call, which makes data retrieval faster and more efficient. Another example is the analyze command that collects stats about a table. With streaming I/O, it improves analyze performance by fetching and reading example data blocks more effectively. I/O combining allows larger vectored I/O requests instead of issuing multiple small I/O requests, and thus reduce the system call overhead. Let's take a look at comparison. In Postgres 16, it doesn't have I/O combining, and it has to issue this long list of small AK I/O requests. With Postgres 17, I/O requests can now be combined into larger chunks, resulting in much less requests. Union Planner executes each of the subqueries, then sort and duplicates the results to combine them together. When you are dealing with a large data set, you can see the sorting can become a bottleneck. We improved the Union Planner performance by leveraging the merge append to eliminate the sorting on the top level when the subqueries are already sorted. Here, let's look at the comparison again. With Postgres 16, you can see the Union Planner does sequential scan for both of the subqueries and then sort at the top level. Postgres 17, since the column has index, meaning it's already sorted, the Union Planner now uses index-only scan of the subqueries and then merge append at the top level. No sorting at the top level is needed. Now chicken string optimization eliminates the redundant not now filter when not now is already specified as a column constraint. Here, in this example, column A in table T has a not now constraint, which means that column will never take a null value. With Postgres 16, if you later want to select all values of A and I want to make sure those values are not null, it will again apply filter to filter out all null values, even though column A can never be null to begin with. With Postgres 17, it is smart enough to skip this redundant filter. Vacuum. Vacuum in Postgres is essential to keep database healthy by reclaiming storage after rows are deleted or updated. Every essential operation of database will generate a WAR record. The vacuum improvement reduces the number of WAR records and thus improves the storage efficiency. Let's take a look at the example again. In Postgres 16, as you can see, pruning and freezing are two separate steps of the vacuum process and thus produce two WAR records. With Postgres 17, it combines the pruning and freezing steps to one, so that only one WAR record is generated, reducing the WAR volume by 50%. So besides adding all the above new capabilities to Postgres core, Microsoft also contributes to the Postgres ecosystem with Porcuni improvement. So Porcuni is an open source tool to manage high availability for your Postgres databases. Porcuni 4.0 release adds support for quorum-based failover, enhanced CIDR support, and configurable retention of members' replication slots. Now let's talk about AI. We have building AI capabilities of Azure Database for Postgres, and how it enables a seamless experience of building intelligent applications through native vectors, integration with Azure AI, and leveraging Copilot. We all know vector is behind every AI applications. pgvector is an open source extension for Postgres that enables vector operations such as storing, indexing, and querying vectors. It supports multiple distance metrics and indexing for similarity search, which empowers AI applications such as recommendation, question answering, and RAG applications. Since pgvector is a Postgres extension, it integrates seamlessly with Postgres and allows users to leverage their existing database for advanced AI tasks. Another extension, Azure AI extension, is built specifically for the Azure Database for Postgres. It allows direct calls from Azure Postgres Database to Azure AI services, such as Azure OpenAI, Azure Language Service, Azure AI Translator, and Azure Machine Learning. Azure AI provides SQL-based interfaces, making it very easier for our database developer who are already very familiar with the SQL. It also simplifies the AI application development process by enabling AI capability right there at the database level. To allow any Postgres user to leverage this wonderful AI extension, we plan to open source Azure AI very soon. So lastly, I want to point out all the above new capabilities to Postgres called the AI extensions. Postgres 17 are available with our Azure Database for Postgres Flexible Server. If you have time, check it out. Now, I'm going to hand over to my coworker, Aditi, to talk about the great things about Azure Database for MySQL.
Thank you, Dingding. Hey everyone, my name is Aditi Gupta and I'm a Senior Product Manager with Azure Database for MySQL. For today's agenda, we'll briefly touch upon MySQL's developer mindshare. Next, we'll talk about all the cool features that you can use to build limitless, trusted, AI-ready apps on MySQL. Last but not the least, we'll have a customer showcase with one of our customers, Quadrant. They'll talk about their onboarding journey to Azure. So let's get started. MySQL is a top choice for building web applications due to its ease of use, scalability, and reliability. 9 of the 10 top websites globally are powered by MySQL. Additionally, 54% of developers build on MySQL. At Azure, we are 100% committed to support the MySQL Community Edition. With Azure Database for MySQL, we want to empower you to build intelligent, scalable, secure, compliant apps. For today's discussion, I want to tackle 3 questions. First, how can you be more limitless with Azure Database for MySQL? Second, how can you build intelligent apps on top of it? And third, how can you onboard to a trusted experience on Azure? So let's dive in. With your MySQL Business Critical Service tier, we want you to be limitless by enabling accelerated logs. This is an out-of-the-box improvement available at no additional cost. The best part, you get a 2x improvement in throughput and latency. Well, don't just take my word for it. We ran a sysbench performance test, and as you can see, with accelerated logs, we've achieved 9,500 transactions per second and an average latency of 13.41 milliseconds. Now on Azure, we are committed to bring you the latest of MySQL versions. And with that, I'm pleased to announce the support for MySQL 8.4 LTS. That means assured ongoing updates over the long term, bringing you the latest in security enhancements and performance optimizations. Next, with the MySQL 9.1 innovation release, you can now add AI wings to your MySQL instance. This brings in a new vector data type support for create and alter statements and support for JavaScript-based stored programs and functions. Now, this is as simple as navigating to the Azure portal and creating your Azure Database for MySQL Flexible Server instance. Selecting version 9.1 for your server, MySQL server, and putting in the rest of the server details. Now let's go ahead and create a server. Now that the server is provisioned, I'll navigate to the databases blade and create a new test database. Moving ahead, via the PowerShell, I'll connect to the very same MySQL instance that we've just deployed. As you can see, the server version is 9.1. I'll go on and create a test table with 2 vector fields. Now I can easily add high-dimensional vector data here and retrieve the consequent vector embeddings, fueling AI experimentation with MySQL. Now that we've made the database intelligent, let's take a look as to how can you make scalable apps on top of it. I'm pleased to announce the public preview for deploying one of the most popular open-source e-commerce applications in Azure. With the single-click Magento app deployment, you can now deploy all the supporting infra with a single click. And you can build intelligence into your Magento application with integrations with Azure OpenAI and Azure AI Search. Let's take a quick look. We've published a one-click ARM template to deploy the Magento application on Azure. This deploys all resources right from AKS to Azure CDN to the flexible server in a secure setting. The deployment steps are as simple as following through a few prerequisites and clicking on the Deploy to Azure button here. Now, this is going to take us to a custom deployment template. It's going to ask me for a few critical input details so that all these stitched components can be deployed successfully, such as the Magento blueprint, the Redis cache, and the MySQL Flexible Server version 8.0, which is the most popular version for your enterprise production workloads. Now that I have all my inputs in, let's go ahead and trigger this deployment. Now that the deployment is successful, let's navigate to the AKS workload that is hosting our Magento application. I'm going to go ahead and click on external IP here, and our online store is up and running in minutes. But hey, I want to do more. Building on the integrations with MySQL Indexer, Azure OpenAI, and Azure AI Search, I can now add an interactive Copilot experience to my application. Next, we are going to take a look as to how search materializes on a vanilla Magento application that we deployed versus the interactive recommender Copilot that we've built on top of it. So on the application here, I'm going to type in a very simple prompt. Suggest me some products for carrying my stuff for a workout. Let's see how that fares on the vanilla Magento application that we built earlier. Hey, none of these products here are going to fit in everything for going to a workout. But let's see how our recommender Copilot does. It finally returns the products that we were looking for through a prompt. The summarized reviews help my customers make an informed decision, truly making my application intelligent. Moving ahead, we want you to have a trusted developer experience on Azure. And with that, I'm pleased to announce coming soon in December the public preview of default zonal resiliency for your business critical service tier. What this means is you don't have to enable HA anymore. We are still going to host your data and log files in zone redundant storage at no additional cost. Now, before I move on to the next section, I have a quick question for the folks in here. How many of you have dreaded getting a new laptop or a mobile phone just because of the logistical nightmare involved in migrating your data or apps? Anyone? Well, I am one of them for sure. But I think with the investments that we are making in the migration space today, I can change your mind about migrations. So coming up first is the public preview of MySQL discovery and assessment in Azure Migrate this December. You can now perform shallow discovery and deep discovery of your MySQL instances along with their attributes in their environment. Next, you can assess the readiness of your MySQL instances to migrate to Azure Database for MySQL. And lastly, you can get the right compute and storage SKU recommendation along with their corresponding costs. Well, we do not stop here. We still have some exciting news to share as to how can you optimize the Herculean task of actually performing a migration. So in this space, coming soon in December in public preview is a unified migration experience with Azure DMS for sources such as MySQL on-prem or your VM workloads. Now, this takes physical backup files that you've taken via Percona Extra Backup and restores them to an Azure database for MySQL flexible server instance. So this is going to be an online migration with minimal downtime, does migrate your logins as well, and the best part, this is the fastest migration path for such sources. You can now migrate your 1 TB workload in just 22 minutes. So let's take a quick look at the demo. So for the demo here, I'm going to create an Azure Database migration project and trigger a new activity for physical online data migration. For the source server, I have a MySQL workload on Azure VM. And for the target server, I've pre-provisioned an Azure Database for MySQL flexible server. So let's go ahead and kickstart this activity. So the source details gets all my VM details in here. Next, on the target, the pre-provisioned flexible server in South Central US, and on the databases, it's just the system databases that we have. We'll move on to the backup pane. For here, first we'll go to the Microsoft Entra Admin Center and create our app registration. Now we are going to use this app to authorize any request on behalf of the user. Next, I've created an Azure blob here, and this folder is going to store any extra backup files that we want to import from. Once we have these details, let's head back to our wizard and go ahead and review our migration details. Let's start this migration. As you can see, the initial load is running. You can now see the estimated time remaining as well computed for your migration. Once the initial load is completed, we are going to cascade into the replicate data changes blade. You can see the replication changes here as well as the bin log details. We are going to be monitoring the seconds behind source. As soon as it is 0, that means your target has caught up with the source, and we are ready to do our cutover. Let's go ahead and complete our cutover. The only thing left now is to validate our flexible server. And as you can see, we successfully migrated 2 user databases here. Well, at Microsoft, we believe the proof is in the pudding, and I'm excited to call Prasanth Tammiraju, Technical Director, Data and AI from Quadrant, to talk about his onboarding experience to Azure.
Hey, Aditi. Good morning, everyone.
Hey, Prasanth, we are very excited to have you on stage here with us. I would love you to tell our audience as to what challenges did you face when you were deciding to migrate to Azure?
So when we had decided to migrate to Azure, the core challenges that we were facing is the compatibility between applications and databases, and what kind of right SKUs that we need to identify, and what are the kind of upfront costs that we are going to incur in terms of the migration. So these were the few of the challenges that we faced.
Thank you. To get past these challenges, what was the solution adopted?
So we tested the Azure Migrate MySQL for our MySQL workloads, the discovery and assessment end-to-end.
Thanks for sharing that, Prasanth. Additionally, can you tell us what benefits have you reaped out of Azure Migrate?
Sure. So Azure Migrate provided us a structured approach in assessing our on-premise workloads, making sure we understand the target SKUs and what is the overall cost involved, which would really give us the potential to perform a phase-wise migration in order to make sure we have a smooth transition with respect to our end-to-end migration with efficiency as well as cost efficiency.
Thanks so much. With that, I'll let you take the stage away to give us a short demo.
Thank you. So let's look at the demo, how we were able to achieve this. So we first create a Azure Migrate project. Within this, we select all the required instances. We discover using appliance. And from there, we download that appliance onto a Windows server. And once we download it, we provide the Linux or Windows credentials, and we do the discovery. Once we start the discovery, and once it's completed, you will be able to see your list of servers within the Azure portal. And to have a deep dive into that, we have to install a Kubernetes appliance onto the Linux machine. And post that, you'll be able to drill down into details where we have to provide the credentials for MySQL and the OS in order to be able to retrieve the performance data as well as configuration data. And post that, we are ready to perform our assessment on the list of MySQL servers that we have provided. So it gives all the detailed attributes along with the server details. And here is when we can get started with our assessment. We click on the MySQL database. We can provide the assessment settings here, so where we have to configure it based on the performance history, 1 day, week, and then select the service tier. And accordingly, we can trigger the assessment with the assessment name and the list of servers that we want our assessment to be done on. Once the assessment is completed, we have a detailed information about the overall assessment. The dashboard gives us a clear picture about the readiness, about the instances of databases which are migrated, and we can even see within the overview page what are the version details and the end-of-life details pretty clearly. So this gives a complete robust information about our overall assessment, where below grid shows a list of SQL instances with readiness and non-readiness. If I select a SQL instance, you see the tabs, readiness, source properties, target recommendations, which gives a clear picture about what are all the list of source information that was taken into consideration, what are the properties that we have based on the performance and configuration, the vCores, cost, etc., and what is the target recommended SKU with this list of vCores and why that SKU has been selected. So there is a detailed recommendation also provided, and we can also see the user databases with the database size. So this entire information can be downloaded. Yes, along with that, we also have, whenever we have a non-readiness, we do have detailed migration issues, and there are 30+ checks that have been run on these MySQL servers, which will clearly provide us the path towards the MySQL migration readiness. So that's how comprehensive this end-to-end product is. And all this can be downloaded into a well-defined Excel sheet, which we can utilize for an offline information or a further analysis. So all this is really helpful for us. It really helped us to migrate end-to-end and reduce our overall infrastructure cost. Over to you, Aditi.
Thank you so much. The Azure Database for MySQL team is at the expert meetup booth on level 3. If you're looking to reduce costs for your LAMP applications and move to a packaged applications, or have any other questions on MySQL, please do come talk to us. And with that, I'd like to call on stage my colleague, AVIJIT.
Yeah, thanks, Aditi. And thanks, Prasanth, for sharing your experience, onboarding experience with us. Hi, everyone. My name is AVIJIT Gupta, and I'm the Senior PM on Azure Cosmos DB team. So far through the session, we have learned on how Azure contributes and enhances the open source database ecosystem and how exactly it adds the cloud native capabilities to them. Now, Azure Cosmos DB extends this by offering a fully managed, globally distributed, and open source, low latency service, which is highly scalable and ideal for building mission critical applications. The service went GA in 2017, and it solved for the problems of infinite scalability along with getting the 5 nines of availability for the services. Now, having these goals met, now we focus on making solutions easy to use for the developers. And one fun fact about the AI readiness is that the ChatGPT that we use all around is actually using Azure Cosmos DB as its backend. So yeah, why we created the database based on open source MongoDB protocol. This happened because we wanted to offer our developers a flexible, high-performance solution which could integrate smoothly with your existing MongoDB applications. Here we are actually leveraging the strengths of Cosmos DB, which allows you to provide a platform enhancing the performance and reliability of the solution. And developers also benefit from the built-in security, high availability, and the ability to scale effortlessly. The combination of MongoDB protocol along with the Cosmos provides developers the best of the both worlds. So to further improve the developers' data tooling experience, we are releasing open source extension to Visual Studio Code that we are going to talk about as we move ahead with our demo. Okay, so now talking about the vCore-based Azure Cosmos DB for MongoDB, which happens to be our latest offering, built ground up with a custom underlying system and development framework to offer a fully managed experience to our customers. Now, this managed service ensures that you get all the benefits of MongoDB while still avoiding the operational overhead of doing the database administration tasks at your end. Now, our decision to support the MongoDB wired protocol allows us to continue to use our existing MongoDB tools, SDKs, and as well as the drivers that we are using right now in our application, which means the compatibility is so seamless that you can easily utilize your existing knowledge and investments and get transition to this service. Then we also offer Azure native integrations, such as there's Azure Monitor integrations, Azure CLI, diagnostic logs, and more, which provides a comprehensive end-to-end experience for our developers. Our key value proposition lies with the AI integrations we offer, which harnesses our advanced vector capabilities and the support for DiskANN, which optimizes for the performance. Our internal benchmark shows that there is a 10x improvement in throughput for vector queries compared to any other MongoDB protocol database available out there in the market. And another key highlight here is the vertical scaling capability, which allows us for independent scaling of CPUs and storage. We offer 8 times more storage per node than any other MongoDB protocol compatible database. So effectively, this brings cost efficiency to the businesses like healthcare, banking, and insurance, which requires storing data up to 7 years, as in for the compliance reasons. To enhance the scaling experience for the developers, we are introducing auto-scale instances with Ignite, so which allows us for, this allows us to perform the instant scale-up operation, which means that there won't be a need to rebalance the data, which means like we will immediately get the consistent performance while we are working with the solution, and it also brings the cost efficiency to us, right? Auto-scale instances are critical for industries like e-commerce or finance, where maintaining a seamless operations during the peak hours is essential, right? And lastly, our ability to independently price the SKUs and storage allows us to offer the database at a significantly lower total cost of ownership. At scale, we have observed these benefits to become more pronounced, wherein one of our customers reported an 80% of cost saving while onboarding to the service. Now, Yeah, so we'll move into the demo where we are provisioning the cluster, and then followed by that, we are getting into the usage of Visual Studio Code extension. So here we are starting with provisioning an Azure Cosmos DB for MongoDB service. And presented with the two architecture options, we'll go ahead and provision a vCore-based cluster. Now, filling in the other details, we want to focus on the global distribution option, which allows us to provision cross-region replicas, essential to get the benefits. Like first is cross-DR benefits that we want, as well as it benefits the globally distributed users as well. Now, moving on to the cluster tier. Cluster tier presents us with several SKU options that we can choose from. And similarly, we also get to choose the storages, wherein we are now, we have introduced the large disk storages with Ignite. And this is kind of critical for systems, as in like it gets the cost efficiency to the systems which require storing up to like large data for like, as in like over time, 7 years of data that we mentioned earlier, right? Now moving on to the shards. So shards represents our horizontally scalable nodes in the cluster. And we now support up to 5 shards. It shows preview, but now it went GA with Ignite. So yeah, so we'll save that and we'll trigger the deployment, which provisions our cluster. Now, moving on to the Visual Studio Code extension, so we saw that we are able to find the extension on the marketplace, and then going into the Azure tab, you can find these subscriptions listed under the account that you are connected with. And under each of these subscriptions, you are able to see the different services that are provisioned under your account, right? We have provisioned a vCore cluster, so we'll go ahead and try to get connected with the cluster that we just provisioned. We will perform some basic activities, like we'll go ahead and create a database, and then we are creating a collection. And now followed by that, we are going to import some data into this collection. So we see the 200 documents inserted now, right? Now, we'll go ahead and next thing, we'll do the visualization. We'll look at the visualization. So the extension actually provides us with 3 different visualizations, which is table view, tree view, and JSON view. Table view happens to be giving a familiarity to the developers who are coming from the RDBMS background. And tree view happens to be intuitive to go through the, like identify and go through the complex structures where we have nested documents. We can also do querying on the system, and here we have done a query on zip code, and we have got the documents, right? Now, additionally, we can export the result set that we have got from the tool itself. Other thing that we can do from this extension is, we see that we are able to connect to a Mongo RU cluster as well. So it has the ability to connect with other MongoDB protocol databases as well. And at last, at the bottom, we have the ability to be able to connect to any external MongoDB compatible database as well. Yeah, so yeah, that closes our demo. OK, so now I'll go ahead and summarize our key takeaways from the session today. So we learned here on how Microsoft is contributing and committing to the open source databases ecosystem, and are working on making them better by like making them enterprise ready by contributing in different areas. So key steps towards that includes the robust enterprise security, which is integrated to the DBs, the high availability, which guarantees for the continuous availability and scalability, which is required for addressing the business growth. We also observed Azure open source databases seamless integration with Azure AI and machine learning services, which allows to build intelligent AI-ready apps. Azure offers all of this as a fully managed bundle, which are always up to date with latest industry innovations. And Microsoft offers this at a competitive pricing model that makes these databases cost effective. OK, so this is, we are launching a developer voice advisory program in December. And if there are application developers here, we would encourage your participation. This is a great opportunity where you can actually be part of the community and try to influence the strategic decisions by sharing your requirements with us. So scan this code and probably sign up with us to be able to part of our community. Here are a set of resources that that provides the blogs that provides you more insights about the features that are being released as part of the Ignite, which with all these databases. And on the right, we have a few set of sessions that are being planned for today and tomorrow. So to learn more about these databases and the improvements that we are bringing in with Ignite, I think you should definitely go and join that. And for lastly, I think there is an announcement for the customers who happen to be using Azure Cosmos DB. So we are inviting you to give a product review on Azure Cosmos DB. And in return, you will get a $50 Amazon gift card. All you have to do is find a peer spot person who might be stationed outside this session room, as well as you can find them in the expert meetup zone next to our car simulation area. And additionally, we are also giving some extra special swags, whoever leaves a review for us. So yeah, with that, I think thanks for joining us for the session today. I would like to invite my co-speakers to the stage and probably get started with Q&A. Yeah. Yeah.
Thank you.
Great.
I just want to quickly add to the peer spot. Postgres also running a peer spot. If you have reviews for Postgres, please go ahead to find the crews who has their shirt with the P, the yellow P on top. Any questions?
We have some questions from the online audience.
Okay.
One person asks, is Azure Database for MySQL going to have support for vector search and DiskANN?
So with the innovation release, that's where we are supporting the new vector data type, but we are supporting the MySQL Community Edition on Azure. So right now, we don't have support for DiskANN, but they can use the innovation release to experiment anything AI with MySQL.
Okay, great. And another question. Do you have any sample applications in GitHub for any of the databases discussed today, Postgres, MySQL, and Cosmos?
Yeah, we definitely do. I will provide link, and then you can click a link. Actually, if you just go to the Flexible server, Microsoft Azure Database for Postgres Flex server site, it has actually a sample workload and sample database. And from there, you can get to the GitHub code.
There are sample repos available for like getting through the different options that you want to try out for each of these databases. So definitely you can check it out. We do provide them.
All right, that was a great session.
Thank you.
Thank you so much, everyone.
Thank you for coming. Thank you.
Thank you all.